Hello, my name is Giulia Felappi, and I am a philosopher at the University of Southampton. And in this video, I would like to introduce you to a very famous problem, Newcomb's problem. So, what is the problem? You are confronted with a choice. There are two boxes in front of you, box A and box B. And you can decide either to pick only box B, i.e. be a one boxer, as we call it, or pick both boxes, i.e. be a two boxer. And you can keep what is inside each of the boxes you open. Of course, at first it seems an easy choice. The more, the better. But of course, there is a catch, hence the problem. So you know what is in the first box, box A, you know that it contains £1,000. You don't know, you cannot see what is in box B, but you know that what is in box B has been decided by a super powerful predictor. You know that the predictor has been right about your choices in the past, and you know that the predictor has been right about other people when it comes to this very choice. You have a lot of confidence that the predictor will predict correctly. And Nozick, who was the first to speak about Newcomb problem, as Nozick says, we can tell a science fiction story. The important bit is that the predictor is indeed somebody you have full confidence in. And the predictor put in B money according to the following rule that you know. If the predictor predicted that you would pick both boxes, then they put nothing in B. If instead the predictor predicted that you would pick only box B, the one that you can't see, then they put £1 million in that box. And then here is the catch. Should you be a two boxer, the more the better, or should you be a one boxer? So should you think that the predictor will be correct and then aim at the 1 million? So the Newcomb's problem is called a 1 million problem in philosophy, and now it should be clear why. So one of the reasons why Newcomb's problem is so interesting is that people tend to develop quite quickly an idea about what they want to do and what choice they would go for if they were in the situation. But at the same time, people think that it is impossible to understand the other stance. And people divide quite equally in one boxers and two boxers. So let's quickly see together the bulk of the arguments for being a one boxer and a two boxer. So the argument for being a one boxer fundamentally relies on the claim that the predictor is super powerful. If you want it to be a computer, if you want to be a robot from the future, feel free to think about the predictor in the way that makes them more reliable you can imagine. And then if you think about the predictor, then of course you have here all the four possible outcomes depending on how the predictor predicted and what you choose. So the first option is that you pick both boxes, that is in blue, and the predictor predicted that you indeed were a two boxer. This is very likely, but if they predicted that you would be a two boxer and you are a two boxer, you only get £1,000. The second option is the one in orange in the first row, is that you pick both boxes and the predictor instead made a mistake. So he thought that you would only pick B, so he did put the £1 million in box B. In this case, of course, you get the 1,000 from box A and you also get the million from box B. So in this case, you get 1,000,000. The third option, the first in the second row, the one in orange, is that you pick only box B and the predictor made a mistake. In this case, you are a one boxer, but he predicted that you would be a two boxer, so he didn't put anything in B. The result is that you get nothing. You didn't open A, so you don't get the 1000, and the predictor didn't put the million in B, so you don't get that either. Now, the two options in orange are the options in which the predictor was wrong about you. And if we think about the predictor and the fact that the predictor is indeed going most probably to be right, of course, it's natural to think that the options in orange are very unlikely. The likely options are the one in blue we already saw, the one in which you pick two boxes and the predictor was right about that, so they put nothing in B and you get only 1000. And then the happy situation, the one in which you only pick box B and the predictor was right about you, so they did put 1 million in box B. So you get 1 million. You lose out on the 1000, but you do get the 1 million. And then the reasoning goes, well, there are only two likely scenarios, those in blue. The first one is the one in which you open both boxes and then you end up with 1000. The second is the one in which you pick only box B and you get 1 million. So the one boxer thinks less is more. Let's just pick box B because in this way I go home with 1 million. I don't know whether you are naturally inclined to be a one boxer, but if you are a one boxer, then you might be absolutely confident that this is the right decision to make. If instead you're naturally inclined to be a two boxer, you will probably have intuitively thought about the argument that we are gonna see in a second. If you are a one boxer, check the other way to go. So here is the argument for being a two boxer. The two boxer doesn't focus on the fact that the predictor is reliable. What the two boxer focuses instead on is the fact that when you are asked to make your choice, the prediction already happened and the predictor either did put the money in or didn't, but now the situation is sorted. So when you make your choice, either the money is there or the money isn't there, but it's not that by your choice you can change what is in the boxes. When you make your decision, the prediction was in the past. And then the best way to understand what is the argument for two boxing is to see the following graph with the four options, not in terms of the likelihood of the option, but in a vertical way. So the two boxer says, well, I don't know whether the predictor was correct or not. The first option is the first column and is the one in which the predictor didn't put the money in box B. First alternative, he didn't put the money. Well, if I open both boxes, at least I get the 1000. If I only open box B, he didn't put anything there, so I get nothing. So if the predictor didn't put the money in B, then I'm better off opening both boxes. The second option is that the predictor instead did put the 1 million in box B. Well, but even if this is the situation, still the two boxer thinks the best thing to do is to open both boxes. Because, of course, if the predictor did put the money, then if you open only box B, it is true that you get the million, but you still get an extra 1000 if you open both boxes, and you also get the 1000 from box A. So no matter whether the predictor did or didn't put the money, you are better off if you open both boxes because you anyway get an extra 1000. So here are the two arguments. They both look quite compelling, but of course they are not compatible. So you cannot choose both to open both boxes and only box B. You cannot be a one boxer and a two boxer. It cannot be the best choice both to open both boxes and only to open B. So how to choose? This is the question that the Newcomb's problem asks us to address. And nobody knows. This is an open problem in philosophy and in choice theory, and a lot of surveys have been done, and all the surveys show that there is an equal split between one boxers and two boxers. You can see here, philosophers have been doing surveys. This is from a website about a lot of philosophical experiments, and people divided quite heavily in one boxers and two boxers. Also on The Guardian, they did a survey with more than 30,000 people, and the situation was very similar, more or less a 50-50. So are you a one boxer or a two boxer? And why do you think that is the right choice? Can you understand the reasoning behind the other party? It's very difficult to understand the reasoning behind the other party. I am myself a very convinced two boxer, and I find it hard to understand why people would go for one box. But at the same time, given that half of the people go for one box and they think they are absolutely right about that, then indeed I find Newcomb's problem very puzzling.